Alright everybody, so before we even begin this video, this is the test parts I printed in the last video. This is the wall test. As you see, we have only on this one 5 walls, not 6. The printer could not print the last one. But we have run into some issues. As you can probably tell, there's like imperfections and weird. This is kind of bent here, deformed. And if you look straight on there, probably see this is angled. That's another imperfection that we're going to run into when printing. But these all work well. First two are a little flexible and they get more solid as time goes on. And then we have these pieces here. This here is the slot. Another issue we run into is I laid this thing, I printed it like this, right? Hence the reason why on the bottom it's kind of like not flat. It's kind of like spreads out. I don't know how to fix that. I'll probably look into it. So these pieces do fit. One is tighter than the other. This one I think is the looser one. I will actually go on SolidWorks after I'm done with this to demonstrate. I don't really demonstrate, just show you what their actual sizes are. These are like, I want to say they're like, let me think here. So they're like 0.01 um, or like 0.02 smaller than this, but 0.01 smaller than each other. One is smaller than the other. I think this one's a smaller one than this one. And the next we have is the ring. This is, I don't remember, I think it's zero point 0.5. Yeah, I think it's a ½ inch in diameter. We can demonstrate the ½ inch diameter by actually taking out something that is also ½ inch in diameter, approximately the Nerf dart. And you'll see it kind of fits in there perfectly. Ish. As this one doesn't have the same issue, it kind of like spreads out on the bottom, so it's not completely smooth. Pins, same deal with these as these had. And I'm sorry about the camera; it's a little shaky because I'm recording this with my hand on my cell phone. And yeah, so those are all give me kind of a good idea what we're dealing with. This thing also does, it was good just to check how small it can actually go. These, by the way, are printed on the highest quality 50% infill. But I'll have to make some adjustments and stuff. This also was a good time to try to figure out different printing tactics. Like if when you're gonna print all these things, I did find that what I should probably do, what a lot of people probably should do, is print them in ascending order of like size, so the print head doesn't print over here and then have to go back to print over here, and then because it was doing with these, so it was kind of set up like this. So it had to print here and then go back here and print here, go back here, and it takes a few seconds, like about a second, to go do that. But I think these tests were a success. A good way for me to figure out how much we need to adjust, and we're going to do those adjustments right now. So when we get to SolidWorks, we'll check back in. Alright everybody, today we're going to be continuing our pulley. Not like last episode where I just created these little parts. Today we're actually going to be doing the adjustments. To start, pretty much, we need to go to the actual pulley assembly right now. I'm going to go do that right now. And I actually want to check some of that's print 3D. That's not it. Where is it? Not there either. It's, yeah, I was testing Lego parts. Pulley 2. Yeah, pulley 2. I'm actually going to take the pulley assembly. I don't want to do that. I want full on assembly. Just the assembly right now. And I want to see, check some stuff. Yeah, it's fine to rebuild it. We'll save it too. We need to check some sizes, the clearances and stuff already. But as you've seen beforehand, at the beginning of the video, we had looked at our parts, that I'm fumbling around with right now. And I've discovered which sizes will work better than others. Um, yeah, so we have the pins and wheels. That's probably the easiest one, I'd say. The easiest one would be the distance, not the distance, the size of this hole and the clearances between the big pin and the actual wheel itself. So that's going to be the easy part. Then we need to figure out how to like friction fit. I kind of figured out how to do that. It's just, I'm guessing all I have to do is just a tad bit bigger, because both pins that I printed do not fit in. They're not tight enough, and we'll have to look into that. I think I know a good number though. I think we instead of going 0.48 to fit into a hole that is 0.5, I think we go 0.49 or 0.85. 485. Go even farther down. And then for here, the wheel here, I think we're good. I'll have to check into that too. Actually, we'll just expand this. Probably not, actually. Let's go check. The distance between these two walls is 6'4", and then the actual pulley wheel, I think, is just straight up 6, right? Keep clicking that. Go to a wall. Click the face there. That face and that face. Yeah, it's just straight 6. That's good enough. According to my slot test, we achieved that. Slot test did fine. And it's a lot smaller than that. It was by 0.02 was what the slot test was, and the pieces just slide in and out, no problem. Wall thickness, we already did the wall test, and notice that these are 0.1. 0.1 works wonders. It's a perfectly fine size. I did find that 0.1 is probably on the wall test, it was the final size. I think it's a good size. We'll stick with the 0.1 wall size. This thing will definitely be a little bit easier to make. The diameter of said pulley. Now, I'm actually going to go a little bit more on the small side. So this is the diameter radius, actually, they would call it. I think it's that 2.4. And this should be like 3, right? 2.5. We are actually going to have to go a lot smaller than that. I'm actually going to probably, for sake of simplicity, probably shrink the pin here. I'll just shrink that down. We'll just open that up right now. And we should go pulley pin. Yeah, pulley pin. This is technically the first half. And we go here, revolve. And I'm actually going to change that number. Look, I don't even know which number it would be. It should be that one. Yeah, that's the actual pin size. So from 0.47, what is it actually now on the wheel? Because the evaluation tool just says perimeter. It's not talking about the diameter. So let's just be sure on that, because this might be good enough in my opinion. I don't need properties. We're not doing that kind of stuff right now. Sketch. We are looking at 1/4 inch. That's beyond 3. Did we do a test like that? Now we're going to go back to open. We go recent files. We did, and it doesn't fare well in my opinion. It fits. It's like loose. But I feel like we should go more to take into account imperfections. It feels fine though. Let me see. Yeah, well, we'll have to like finish them, like take a rotary tool to them and probably sand them down a little bit. But yeah, actually, you know what? It's fine. 0.03 smaller is fine diameter. Now the inner diameter of this is, we did an extrude cut, which is a little odd, but 0.25. Now, if we look at our pin half 2 or whatever we called it, half 2, we'll notice that it's 0.2 under. That is, to me, might be too big or too small. In my opinion, I think we should go 0.24. It's a little risky. In my opinion, it's risky to do this, but it might work because if you see, if we go back to our recent documents, you can see that we did a 0.8. Now 0.8, the pin fits perfectly in there, but it's not tight at all. Not at all any form of tightness. I just go 0.1. I just go 0.01 under, under the size, and I just rebuild and save it. Go back to our pulley, rebuild it, and then go back to isometric view. So that's basically what this is going to be, pretty much. Quickly just go over that. Another issue is probably the actual frame. We'll check the frame right now. I wonder how big those holes were for the base frame. Base frame's holes, which is an extrude cut, are the right size. Okay, so they're about the same size as the actual pulley wheel, which perfectly fine. It can rotate around those too. Get this back to isometric view. That should be it, actually. All the bits and pieces here and there, and we can probably just go over how to, or how I at least, print all the bits out. Now in here you can't actually. I don't think you can. You can print it as a whole file, which is a little dangerous. I've never tried to print this as a whole file. I wonder if I could. I might do an experiment on that in the future, like a future video, if I can see what a complete, like instead of multiple pieces, file would work. So we saved the file. Actually not right now. Cancel. I'm actually gonna have to do this one at a time, don't I? Yeah, we're done with you. No, we have to exit first. Yeah, so we're done with this one here. We're all ready. Yeah, so for SolidWorks, you go up to File, go to Print 3D. You ignore all this and just go straight to Save to File. Not all printers, I think, can use this, but they will normally use an STL file right here, which I can save to my Print 3D folder, which is just a single folder I use. I'm actually going to put these into a new file, a new folder called Pully 2, and we're going to go that up, save the pin there, yeah, pin gets saved, and move on to the next piece, the base. The base is probably going to be I would say probably be the longest to print, just because I'm not printing it flat, I'm printing it straight up like this, and it probably, hopefully, will not fail, and it would be kind of sad if it did. Just put the pulley base there. Yep. I've done a lot of tests, and I'm pretty sure we're ready for this, to print all this stuff. The first pulley, I might be able to like show a video on it at some point, but it's a mess, and I don't really want to mess with it. So I just start from scratch, as I've said before, starting from scratch. Moving on. Now we move on to just gotta get the wheel. The wheel. It's not Print 3D. It's gonna be, of course. We actually have to go to our cheat. Go through another file on that thing. I think this is. I'm gonna pin it. Now I don't want to pin this. I actually want to pin the part file, but I guess I'm not gonna be able to do that. Yeah. So we move on to File. Move over to Print 3D. Save to a. Go back up here to Print 3D on the Pulley 2 and save it. This will be one of the more complicated ones, because first of all, it's not only going to have to print some form of raft, but I have to print support here, and I'm actually going to extend it. This is not going to lay flat on the print platform. I'm actually going to put a raft or support there by lifting up like just slightly above where it's supposed to go, and then leave it at that, and then we can finish that up. So I will have it all printed probably next video, I want to say, where I will probably print it all out, maybe have some footage of the process, might do a little bit of like a montage, and then move on with that. I'll have to learn how to do montages. So that will be the end of the pulley project. Once it's all built, we'll have a print montage kind of thing, then an assembly, and then maybe a comparison to the failed pulley. I actually have most of the pieces, um, and yeah, so we'll deal with that. So stay tuned for that. Hope you enjoyed today's video, and we'll see you next time.